We're learning about proportions and problem solving with rational equations. I know I've got this when I can solve proportions, use proportions to solve problems, and solve problems about numbers, work, and distance. Key vocabulary is a ratio is the quotient of two numbers or two quantities. A proportion is two ratios or rates that are equal to each other. So a ratio is just one quotient of two numbers. A proportion is two ratios that are equal to each other. Some people get ratio and proportion mixed up, so that's what it is. Cross products is when you're multiplying proportions diagonally to solve. And similar triangles, the measures of the corresponding angles are equal and the corresponding sides are in proportion. A ratio, again, is the quotient of two numbers or two quantities. And it's anything that can be written as A to B or A over B. A proportion, again, is two ratios or rates that are equal to each other. So we're going to solve the proportion for x. So we're solving for x. And we're going to do this by cross multiplying. All right, so we're going to cross multiply. So I'm going to multiply 5 times x plus 2, and then I'm going to multiply 3 times x plus 1, and just solve. So I would get 5x plus 10 equals 3x plus 3, and then combine like terms. So I'm going to subtract the 3x from both sides. 2x plus 10 equals 3. Subtract the 10. Now we get 2x equals negative 7. Divide that 2, and I would get x equals negative 7 over 2. (1b), we're going to do the same thing. So we're going to cross multiply 3 times x plus 2 and set that equal to 5 times x minus 5. So we're cross multiplying here and here. So distribute 3x plus 6 equals 5x minus 25. Combine like terms, so I'd subtract the 3x from both sides. Now we get 6 equals 2x minus 25. Add the 25 to both sides, and you would get 31 equals 2x. Divide both sides by 2, and you get x equals 31 over 2. Okay. Now we're going to do a word problem ratio. So if a 170-pound person weighs approximately 65 pounds on Mars, how much does a 9,000-pound satellite weigh? So we're going to set up a ratio. A 170-pound person on Earth would equal 65 pounds on Mars. So a 9,000-pound satellite on Earth would weigh how much on Mars? So we cross multiply. So 170 times x equals 9,000 times 65, which is 585,000. Divide both sides by 170, and you get approximately 3,441 pounds. Now you try one. You should have gotten x equals 13 over 3. 1c, try this one also. Go ahead. You should have gotten that it would have 143 calories. Okay, in similar triangles, the measures of corresponding angles are equal and corresponding sides are in proportion. Given the information about two similar triangles, you can often set up a proportion that will allow you to solve for the missing lengths of the sides. So if we were looking at this one right here, we would say for over 3 equals x over 9 because these sides are proportional to each other. And then I can cross multiply and solve. So x would actually equal 12. All right, so given the following triangles, find the unknown length of y. So 12 over 10 would be equal to 5 over y. You cross multiply, so 12y equals 10 times 5. So 12y equals 50. Divide both sides by 12, and you get y equals 50 over 12, which is equivalent to 25 over 6. Two B says the quotient of a number and 9 times its reciprocal is 1. So find the number. So the quotient of a number n, so quotient means divide, of a number, so n, and 9 times its reciprocal. So its reciprocal would be 1 over n, and then you do 9 times that. So that would be setting it up. Then you actually multiply. So if I'm multiplying, so this says, okay, so 9 times n, 9 times 1 over n would be 9 over n, right? But we have to divide that, so they're multiplying by the reciprocal. So you get 9 squared equals 9, and then take the square root of both sides, and you would get positive and negative 3. Another way to look at that is this. If you have 9 squared equals 9, if you have a quadratic term, you would set one side equal to 0, and you would factor that and set each of your factors equal to 0, so you would get 3 and negative 3. All right, here is a triangle problem for you to do, so I'm going to go ahead and pause this and let you try it. You should have found that the missing length is 15 yards. Okay, next problem. The quotient of a number in 6 minus 5/3 is the quotient of the number in 2. Find the number. So you try this one. You should have gotten that the number is negative 5. An experienced roofer can roof a house in 26 hours. A beginning roofer needs 39 hours to do the same job. How long will it take if both of them work together? So we're going to let T equal time and hours to complete the job together. Then 1 over T is the part of the job they both complete. So you can set it up in a table if you'd like. Okay, so we do the experienced roofer is his part is 1 over 26, plus the inexperienced roofer is 1 over 39. And together they're completing it in a part of the total. And then you multiply by the least common denominator, which would be 78t. When you do, you would get 3t plus 2t equals 78. 5t equals 78, then divide by 5, and you get the roofers would finish, it would take them 15.6 hours working together to finish the job. So look at the original problem. An experienced roofer can roof a house in 26 hours. So his part is 26 hours. His helper, or an unexperienced, a beginner, is 39 hours. Find how long it takes them to do it together. So that's how I would set up the equation. The speed of the lazy river's current is 5 miles per hour. A boat travels 20 miles downstream in the same time as traveling 10 miles upstream. Find the speed of the boat in the river. Okay, so read and reread that problem. We are dealing with a distance problem. By using the formula D equals RT, distance equals rate times time, we can rewrite the formula to find that T equals D over R. Now, why would we want to do that? Because it says, well, let's see. We note that the rate of the boat downstream would be the rate of the boat in still water plus the rate of the current, and the rate of the boat upstream would be the rate in still water minus the current. Because if you're going downstream, the current is going to push you along. If you're going upstream, the current's going to slow you down. Okay, so we're going to set up this this table. You can do that. So distance equals rate times time. So if distance equals rate times time, then that means that time equals distance divided by rate. Okay? So let's read it again. The speed of the lazy river's current is 5 miles an hour. So that's what we're adding to the speed and subtracting from the speed of the boat. The boat takes 20 miles, travels 20 miles downstream in the same time as traveling 10 miles upstream. So if they have the same time, that's why we're going to set them equal to each other. So if I have the distance is 20 and the rate, I know that current is pushing me along at 5 miles an hour, then I can set it up time equals distance over rate. So 20 divided by r plus 5. Going upstream, remember the current is slowing it down, so it's 10 miles upstream, so over rate minus 5. Now you just cross multiply and you solve. So if I do that, I'm going to get 10 times r plus 5 will equal the same time, 20 times r minus 5. Now distribute, so you have 10r plus 50 equals 20r minus 20 times 5 is 100. Subtract 10r from both sides. You get 50 equals 10r minus 100. So you're going to add 100 to both sides. You get 150 equals 10r. So divide both sides by 10 and you get the rate is 15 miles per hour. So the rate in still water is 15 miles per hour. And that makes sense because if you go back and you plug it in, watch. 20 over 15 plus 5 is equal to 10 over 15 minus 5, because this would be 20 over 20 is equal to 10 over 10, and that is true. They're the same distance because it's 1 is 1. All right, let's try this one. The car travels 180 miles in the same time that a truck takes to travel 120 miles. If the car's speed is 20 miles per hour faster than the truck's, find the car's speed and the truck's speed. So, okay, so clearly we're dealing with a distance problem again, right? So I know that distance equals rate times time. What are we wanting to do? We're going to find the car's speed. So we are looking for the rate. All right. So if I'm solving for rate, that would be distance divided by time right here. Because if I'm isolating the r, I would divide the t, right? Okay, so I'm going to set this up. And for me, it helps if I set it up in a rate times time equals distance problem in a table. It just helps. Okay, so the car travels 180 miles in the same time that a truck travels 120 miles. If the car's speed is 20 miles an hour faster than the truck, so I don't know what the truck's rate is, but the car's rate is 20 miles an hour faster than that, find the rate of both, okay? So I need to set up a formula, okay? So the time is the same in both. Now, what I just noticed is that while this is true, that rate does equal distance over time, since my times are the same, that's what I want to set up. So the time is the same. So if I isolate the t over here, that's equals distance over rate. So I'm actually going to use this equation, okay? So if I say the time of the car, which would be the distance divided by the car's rate, equals the time of the truck, 120 over R. I can set up that formula because it says if the car speed, find the car speed and the truck speed, but they travel in the same time, So time is equal, so that's what you want to isolate, okay? So we are going to cross multiply. I would get 180R equals 120 times R plus 20. So 180R equals 120R plus, if I multiply that, I would get 2400. So I'm going to subtract 120R from both sides. Now we get 60R equals 2400. So if I divide both sides by 60, I get R equals 40, which means that this R, the truck's rate, is 40. And then the car's is 20 faster than that, right? So the car's rate would be 60 miles per hour. All right, here's one for you to do. So I'm going to pause it. You should do the same and work it out. So you should have gotten 2.4 hours for them to do it together. All right, here's some extra practice. I want you to pause this and try to work it out. And then here are the answers for you to check. So I know I've got this when I can solve problems, solve proportion problems, use proportions to solve problems, and solve problems about numbers, work, and distance. Do you really understand? What are two different methods you could use to solve a proportion such as that? Well, you can cross multiply, or you can multiply both sides of the equation by the least common denominator, which is x times x minus 1. What equation could you use to solve the problem below? Jim can paint a fence in 10 hours. Carlos can paint it in 8 hours. How long will it take the boys to paint the fence if they work together? And that would be the formula.